In this video I want to do a proof involving the dot product. So we're all taught in physics that the dot product of A and B is equal to AB cosine theta, or it's equal to A1B1 plus A2B2 plus A3B3, and we're told to accept the equivalence of these two definitions on faith with no proof, and that really annoys me. I like to understand every fact I learn in math and physics, and what I mean by that is I like to convince myself that said fact is true. So in this video we're going to attempt to prove the equivalence of these two definitions. Pause the video right now and try it on your own. Alright, let's do it. So I remember I've done a proof like this before, but I don't know if I think I did 3 dimensions, but I wasn't sure. Anyway, I started out with 3 dimensions. I wanted to get, like, if I were in 3 dimensions, what that would mean, and that I like to operate in this type of 3-dimensional coordinate system to see how it's defined. Imagine we're just writing on paper our x and y axis as in the usual way, then the z axis would point up from the paper. Alright, I was sort of remembering that maybe I couldn't before. I don't know if I did 3 dimensions, maybe it was just 2. So I started out doing 2 dimensions and simplified it even more by saying, well, maybe I assumed that A lied along the positive x-axis. And then I realized, well, maybe I can maybe I don't have to be that specific. Maybe I can just let A and B be any old vectors in 2 dimensions. So let's try it that way. Notice how I'm defining their angles. So I measure counterclockwise from the positive x-axis. I call this equal alpha, this equal beta, and I just stop when I reach the vector. I don't keep going around and around. All right, this is a useful proof technique. What I usually do, what I frequently do when I prove something is I go backwards. I start by writing my goal, what I want to prove. So I want to prove that the 2 definitions in 2 dimensions, again, are equivalent. So I write that, and then I'm going to use this useful symbol, which is a double-headed arrow, which means I'm connecting 2 statements that are either both true or both false. In other words, I'm connecting 2 statements with the same truth value. In other words, I'm connecting 2 statements that are equivalent. All right, so on the left side, I use trigonometry to rewrite the left side. So for instance, A1 is A cosine alpha, B1 is B cosine beta, A2 is A sine alpha, B2 is B sine beta. And on the right side, I want to get an expression for theta angle between the 2 vectors, and I convince myself that it's equal to beta minus alpha without loss of generality, no matter how these vectors are situated. And one way I did to convince myself of that fact was I used the fact that cosine was an even function. All right, well, this last equation is obviously true by the difference formula for cosine. I mentioned in one of my videos the sum and difference formulas for sine and cosine are fundamental to math and physics, and here's one example of that. I do again think it's important to prove to yourself every single fact that you learn in math and physics, and this is one example. I do have videos proving the sum and difference angles, the sum and difference formulas for sine and cosine. I hope to do a video soon where I can generalize this to 3 dimensions, because we just did 2 dimensions today. Alright, or this video. Now please support me through PayPal to devinwyndham@gmail.com. I also do tutoring both online and in person. If you're interested in tutoring, you can reach me at this email. I am based in Fairfax, Virginia. Please support my YouTube channel. Please subscribe to it.